In the world of aviation, progress is usually measured in size, power, and dramatic leaps in technology. For decades, the aircraft that reshaped long-haul travel were the giants of the sky. Massive twin-aisle machines crossing oceans and connecting continents. But in the early decades of the 21st century, a quieter revolution began to unfold. It did not come from the biggest aircraft ever built. Instead, it came from a single-aisle jet designed to fly distances once reserved for wide-bodies. This is the story of the A321 XLR, the extra-long-range member of the Airbus A320 family, and an aircraft that is redefining what long-haul travel looks like. To understand why the A321 XLR matters, we need to look back at how long-haul aviation traditionally worked. For most of modern history, crossing oceans or flying between continents meant stepping aboard a large aircraft with two aisles. These wide-bodies existed for a simple economic reason. Older engines and older aerodynamics required high fuel burn, which meant airlines needed many seats to spread the cost across hundreds of passengers. This created a global network built around major hubs. If you lived in a medium-sized city, you almost always had to travel through a giant airport like London Heathrow, New York, John F. Kennedy, Frankfurt, Singapore Changi, or Dubai. Direct long-haul flights were reserved only for the largest metropolitan areas. But as travel demand grew, and as passenger behavior evolved, airlines began to notice a powerful trend. People increasingly preferred to fly directly to where they wanted to go. They wanted convenience, speed, and fewer transfers. They wanted to avoid the stress of connecting through crowded hubs. They wanted point-to-point service. At the same time, airports in secondary cities wanted the economic benefits that come with direct international flights. The challenge was scale. Many of these city pairs simply did not have enough demand to fill a wide-body aircraft. Flying a large twin-aisle jet with too many empty seats was financially impossible, even on routes that passengers wanted. This created an opportunity, and Airbus recognized it earlier than most. The Airbus A320 family, which had become one of the most successful single-aisle families in history, already had the efficiency and versatility airlines loved. When Airbus introduced the A320neo program, the new engine option, the family became even more capable. With new engines, aerodynamic refinements, and lower fuel burn, Airbus saw potential in the largest member of the family, the A321. The first major expansion of that potential came in the form of the A321LR, the long-range version. The LR proved that a single-aisle jet could cross the Atlantic Ocean efficiently and comfortably. But airlines wanted more. They wanted to fly deeper into continents. They wanted to replace aging aircraft like the legendary 757. They wanted to open long, thin routes, long in distance, thin in passenger numbers, and they wanted an aircraft sized perfectly for those missions. This demand led Airbus to develop one of the most significant narrow-body aircraft of the modern era, the A321 XLR. What makes the A321 XLR remarkable is not just its range, though its range is extraordinary for a single-aisle jet. The aircraft is capable of flying roughly 4,700 nautical miles, or about 8,700 kilometers. This opens up routes like New York to Rome, London to Miami, Helsinki to Delhi, and countless other city pairs across Asia, Africa, Europe, and the Americas. For many travelers, it will be the first time their hometown airport has ever offered direct service to another continent. The heart of the A321 XLR's capability comes from a major engineering innovation, its integrated fuel system. Earlier long-range variants of the A321 carried removable auxiliary tanks, but those tanks added weight and consumed space. The XLR introduces a completely new rear center tank built directly into the structure of the aircraft. This tank is lighter, more efficient, safer, and able to hold far more fuel than previous designs. It is the key that unlocks the aircraft's impressive range. To support these capabilities, the aircraft receives strengthened landing gear, modifications to the wing structure, and updates to high-lift devices such as flaps and slats. All of these changes ensure that even when loaded with the extra fuel needed for long-haul missions, the aircraft can take off and land safely on a wide variety of runways. And since these flights can last 8 or 9 or even 10 hours, Airbus also refined the cabin experience. Airlines can install full flat business class seats, premium cabins, advanced lighting systems, and larger overhead bins. Passengers often find that the onboard experience feels closer to a widebody than any previous narrowbody aircraft. For airlines, the A321 XLR quickly became a dream come true. It offers dramatically lower operating costs compared to a widebody flying the same distance. It allows airlines to launch long-haul routes that were previously impossible or unprofitable. It can serve medium-sized cities that never had direct intercontinental service before. And, perhaps most importantly, it fits seamlessly into the existing A320 family. Pilots already certified on the A320 can fly the XLR with minimal additional training. Maintenance crews can work on it with familiar tools, familiar systems, and familiar processes. This commonality saves airlines enormous amounts of money and reduces operational complexity. When Airbus announced the aircraft, airlines around the world rushed to place orders. Carriers in North America saw the opportunity to connect cities like Boston, Philadelphia, Baltimore, and Portland directly to Europe. European airlines planned new routes into Africa, the Middle East, and South Asia. In the Asia-Pacific region, airlines viewed the XLR as a perfect tool for long, thin routes across the vast distances of the region. Low-cost carriers saw a chance to expand long-haul, low-fare travel in ways never previously possible. For each of these airlines, the A321 XLR represented something powerful: flexibility, efficiency, and new revenue without the cost burden of a large wide-body fleet. Its arrival also created a strategic shockwave for Boeing. For years, Boeing had dominated the so-called middle of the market with the 757, an aircraft beloved for its range and performance. But Boeing retired the 757 without a true replacement. As a result, Airbus stepped into that space with the A321 XLR and quickly took the lead. Boeing considered launching a new aircraft to compete, but delays, changing priorities, and the crisis surrounding the 737 MAX disrupted those plans. For now, Airbus holds a near monopoly on long-range narrow-body travel. Of course, no aircraft enters service without challenges. Regulators examined the A321 XLR's new fuel tank design closely, insisting on robust fire protection, insulation, and structural integrity. Airbus made design revisions and enhancements, which added some weight but increased safety and earned the confidence of aviation authorities. Long-range narrow-body flights also require extended-range, twin-engine operational approval, a rigorous standard that ensures aircraft can safely fly long distances from diversion airports. Airbus, with its long history of building dependable long-range twins, pursued these requirements with care and confidence. For passengers, the A321 XLR brings benefits they will feel directly. They will have access to more direct flights from more cities. They will spend less time connecting through crowded hubs. They will have a chance to fly on new long-haul routes served by aircraft sized perfectly for demand. And because the aircraft burns less fuel and costs less to operate, fares on some routes may become more affordable, helping airlines compete while keeping ticket prices under control. Behind the scenes, the aircraft is reshaping how airlines build their global networks. Instead of relying solely on giant hub-and-spoke operations, airlines can now spread flights across a wider network of smaller airports. This benefits regional economies, distributes traffic more evenly, and gives passengers choices they never had before. A city that once could never justify daily service from a large widebody can now enjoy direct service from an A321 XLR several times a week, or even daily. For Airbus, the aircraft is a strategic triumph. It strengthens the A320 family and reinforces Airbus's advantage in the single-aisle market. It helps airlines reduce emissions by using less fuel per passenger. It gives Airbus a commanding lead in a segment where Boeing currently has no direct competitor, and it serves as a bridge to the future, where Airbus envisions even more efficient aircraft powered by new fuels and new technologies. In the end, the significance of the A321 XLR is not only in its engineering, it is in the way it changes the shape of global travel. It challenges the old belief that only large twin-aisle aircraft can fly long-haul routes. It empowers airlines to explore new destinations and new business models. It gives passengers more choices and more opportunities to fly directly where they want to go. It proves that innovation is not always about building something bigger. Sometimes, the most transformational ideas come from making something smaller go further, cost less, and open the world in new ways. Some aircraft arrive quietly, joining fleets without shifting the industry. But some aircraft fundamentally change how airlines operate and how people travel. The A321 XLR is one of those rare aircraft. It is the narrowbody that stepped into the long-haul arena, the efficient machine that opened routes once thought impossible, and the aircraft that is shaping the future of aviation one long, thin route at a time.